All right. I'm so glad to see that there are so many that are interested in learning how to crack the code to secure software. But before we jump into the fun stuff, my name is Daniel Deogun. I'm from a company called Omega Point in Stockholm that specializes in security and the crossing between application development.
And my name is Daniel Sawano. I work at a company called Avanza, also based in Sweden. We're an internet-based stockbroker and bank. And in terms of size, we're the biggest actor on the Stockholm Exchange in terms of trade. So that's where I spend my days.
All right, if you're more interested in that, please Google us. So, cracking the code, isn't that really part of a bigger topic called secure by design?
Yeah, so the stuff that we'll be talking about today is very much scraping on the surface of this concept, secure by design, which is basically an approach where you can create secure software without constantly thinking about security explicitly.
So this almost sounds too good to be true.
A little bit of snake oil, right?
Right. I mean, I'm as a developer, nobody's really interested in security, right? So we should be able to somehow use design, but that's also what troubles me. What's design all about?
Yeah, design is a very broad concept. But what we mean by design when we're talking about secure by design is basically any activity that is involving an active decision-making while you are creating your software.
So when I'm drawing stuff on the board with an arrow, is that design?
That's part of the design process. Writing an if statement is your code. You're making an active choice, even if you're not thinking about it. You're making a choice about how should I write that, the criteria that's in the if statement. That's also part of the design process of your software.
So any active decision-making, like a variable name, how you integrate between systems, what kind of language you're using, everything is really part of your design.
Yeah, and the reason for why this, in our experience, works so well is because for the everyday developer, we're all busy thinking about creating features, business features. We don't have time to think, or we're not interested in thinking about cross-site scripting, all these specific security issues. But we're interested and are able to focus on good design. That's something we can do.
Okay, fantastic. But in case you have to run out or you fall asleep, the key takeaway today is really that if you focus on good design principles, you can actually start creating secure software without actively thinking about security.
Yeah, that's what we want you to walk away from all this.
So what you will learn also is that secure by design is not really a replacement for all the other security parts, but secure by design will really narrow the attack surface of your application. And by that, we actually create a better software that's more secure.
Yeah. So enough talking. Let's start to dive into the details. Well, this is what we'll go through today. We'll start off with some of the key design principles. They're called domain primitives and entity snapshots. And then we'll move on to see on how we can actually apply this in the real world on code to make code more robust and more secure. And we'll see how we can utilize our existing infrastructure in terms of continuous integration and continuous development to continuously test our security. And then we'll take a look at something called a domain DOS and see what that is all about.
Yeah, the domain DOS is really fun and scary, and you'll actually learn what that is later on. So let's jump into the first topic called domain primitives. Isn't this like a domain-driven design value object?
Yeah, a lot of the concepts from secure by design builds on concepts that are already existing in domain-driven design, so it helps to know a little bit about DDD. So a value object in DDD is basically a representation of something important in your domain. You represent that as a value object, and what sets a value object apart is that it's totally defined by its value, hence the name.
Okay, so that means like money, for instance, if I have like a 20 zloty bill, that would be, doesn't matter which one I would lend to you, right?
I get a 20 zloty bill from you, and then I can give another one back. We don't care which one it is.
Okay.
It doesn't have an identity, it's just the value 20 that is important.
Right.
And the classical value object also is immutable and has all these properties. So a domain primitive, we're taking that to the next level. We're saying that, okay, not only does it define a important concept, but we're also going to enforce all the invariants that are available in your current domain.
Wow, that's really specific. You're saying that by its mere existence, we know it's true.
Exactly, because we're enforcing those invariants when we're creating the object. So if it's not valid, the data that makes up the object, then the object doesn't exist.
Okay, this is kind of abstract. Let's look at some code. I mean, we're developers, right?
Yeah. So here we have actually designed a domain primitive called quantity, right? So a couple of details. We make the class is final. And we also enforce the invariant that in our current domain, a quantity is not just an integer, it's something between 1 and 200,
right?
Those are the only valid values in our current domain. And then, of course, we can add additional things, and just not a data holder, we can add domain-specific behavior and encapsulate that to gather all the domain logic.
Oh, okay. I think everyone in here agrees that, this is pretty good. I mean, solid design. But this was a talk about security, right? And how can crack the code to it. How does this crack the code to security?
Yeah, you could call this just beautiful code. Well, in order to reason and discuss about security and software, it helps to bring in a couple of terms just to get a framework to discuss around. So if we look at the information security area, they like an app called CIA.
Not Trump CIA, right?
No, not the Trump CIA.
Okay.
But it stands for confidentiality, integrity, and availability, and how they are important for security. So confidentiality. What does that have to do with security?
Well, if you think about it, if you bring in a medical record or something, I'm sure that you think that nobody else except you and perhaps the doctors should be allowed to read that kind of data. So that's really important that we keep the secrets, so to say, right? And then we have, integrity. That's kind of closely related, I guess.
Yeah, it's about making sure the data isn't altered in a way it's not supposed to. A real example, let's say you're sending a message over the internet, and we all know that if we want to, we can attach a hash value to that, and then we can compare it at the end, and we'll know if someone tampered with the data. That's an example of keeping the integrity of the data.
Right. So if you had a shopping basket or an order, you know that if you have passed checkout, you shouldn't be able to add stuff to it afterwards or remove stuff from it. Okay.
Exactly. If I pay for 5 items, I shouldn't add an extra item before it goes off to shipping, and then I get 6, right?
Right. And also availability. That's something that we're quite familiar from I guess, when you build stuff for the cloud, scalability and all that, because availability focuses on making data available when you need it. You shouldn't be blocked or prevented from accessing it.
Yeah, making sure that the data or functionality is available for those who needs it, right?
Okay, so let's jump back to the quantity now and see how we actually addressed some of those concerns with this piece of code.
Okay, so what we can solve here by using domain primitives compared to, let's say, just an int value is we're actually solving the integrity issue here, right? Because the object itself is immutable, and it's not just immutable, it's actually valid and immutable. So we actually get the integrity part.
So that's right, but what about confidentiality?
Well, confidentiality, we don't really solve that with domain primitives because we don't have any, username check or authorization checks. We don't solve that with domain primitives, but we do solve availability.
Oh, yes, you're right, because it's immutable.
Exactly, and what does that have to do with availability?
Well, if it's immutable, we don't need to use any locking, right? And if there's no locking, there's no blocking. So therefore, you can scale it and share it, and it becomes available for whoever needs it.
Yeah, we can pass this around in whatever multi-threaded environment you have, and you don't have to do locks and synchronization and stuff like that.
Okay.
So we actually address 2 issues, right?
That's pretty good.
And availability. And once you start getting all your domain primitives, you will actually end up in your domain with a huge bunch of those, and we can call these your domain primitive library. And then you can start use those building blocks to build the rest of your code, and your code will gradually become more and more robust.
So, but wait a minute, that quantity that we just saw is saying building blocks, how can I reuse it, everywhere? Because quantity of pens is not the same as quantity of, books or cars.
That's a good point. As we saw on the previous slide, an important aspect of the domain primitive is that it's defined in the current context. In whatever business domain or problem-solving domain that you are currently in, that's where it's defined.
Okay.
Okay, so a real-world example, let's say you have an email, an email address. You could say that one definition is the one made by an RFC somewhere, which is, if anyone read it, it's a huge definition of what makes up a valid email address. But you might say, in our domain, we only have a subset of those that are valid. So you have redefined that.
That's true,
in your
because
context.
the email addresses in, I think it's RFC 5322, they're really funky. And those are not the ones that you probably want in your system.
Yeah. So for example, the RFC says that email addresses are case sensitive. But pretty much every implementation of an email functionality is treating the email address as case insensitive.
Right. Okay, so to sum up domain primitives, we know that they're the smallest building block in your domain model, right? They're like the integers, the strings, the float, the doubles, and all that. We're kind of used to using those, but that's not what we are talking about when we're building or solving a problem in a domain, right? We're talking about track number or train or, gate, if you're talking about airplanes and stuff like that, right?
And again, by focusing on this basic design principle, domain primitives, we're solving the integrity and availability issues without actually having to think about those terms or even know about them. So once you can focus on the design, and you will get the security benefits as side effects.
Okay, so immutability was pretty good in the domain primitives, but there's a lot of times when we actually want to, change things, mutate things, right?
Yeah,
so,
true. Pretty much every real-world system needs to mutate data. So how do we handle that? Or do we have any issues with mutable data? Well, actually we do. Well, so let's start with, in DDD, we have this concept of entity, which I would like to explain for the not familiar with it. An entity is something important in your domain that has an identity, all right? So compared to a value object, an entity is not defined by the value of the data, it's defined by some unique identity in our domain.
So that would be like I guess a customer? Could that be it?
Exactly, and if you have a customer in your system, you might assign some numerical ID when the customer first registers. And then you have the data in the customers. It could be address, telephone number. And during the lifetime of that customer in your system, the data of the customer may change. They may change address, change age, change telephone number, but it's still the same customer. So the identity remains as the data itself mutates over time. So that's the difference between an entity and a value object, in a nutshell.
So an entity really isn't unique by its value, but rather by its identity, and has a lifespan, right? Exactly.
So how do we usually model this in code? Well, we model it by creating some kind of object, and we make it mutable. So an example. Oh, sorry.
Let's jump back. There we go. So we have the order here again, right? The order that we said that if you, add an item, it gets added to your order, and then you can check that out, which looks pretty decent. That's what we do. How can you implement a shopping basket otherwise? Right, so this is a classic entity. So is there a problem with this?
Well, we can see that we started to use domain primitives, like the order ID is a domain primitive, so we're starting applying the concepts, but some of the issues we have here is we have a problem with integrity.
Right.
Since you can mutate it, and we don't enforce any specific invariance right now, and if we want to start making sure that we're not altering data, we need to start adding thread locks, synchronization, all that kind of stuff.
Okay, so you're saying that by ensuring that we only allow modification by one thread at a time, we have some sort of locking mechanism outside. Yeah, I guess that would prevent availability eventually. Exactly. If you get a high load. Okay, and integrity, yes. I guess this object could have been modified afterwards or something.
Yeah.
Okay, so, I mean, how should we do it then?
Well, we can introduce something called an entity snapshot, right?
Okay.
And we're solving the problem with immutable state by making mutable state immutable.
What?
How's that for a
I mean,
statement?
we're fixing mutable by immutable.
Yeah.
That's kind of weird.
Okay, well, it's actually not that weird. It exists in our everyday life all the time. So let's say, you know, we have something mutable, like a person moving has a state, the position of the person is constantly changing. Like, so if you can please move, Daniel.
Okay, I'll be running.
He's moving, the state is changing, and then bam, I'll take a snapshot with my camera. So the snapshot is obviously immutable because it's a photo. It's not like one of those live photo
But I
things.
keep running, right?
Yeah, you're
Okay.
keeping running, but my photo is still immutable. And then I can take another photo at a later point in time, and that snapshot is also immutable, right? So it's basically a representation of a mutable state in a certain point of time.
Okay, that was a weird example.
Yeah, sorry.
Let's go back to IT, please.
Okay, so an IT example. Let's say we all use websites. We browse the internet. So you request some information from the server, and then you get a nice page with colors and data. That's a snapshot, right?
Right.
Because the data on the server might change while you're reading the page. Then you have to reload the page, or maybe you're being fancy and pushing data out. But it's still what you're looking at, it's still just a snapshot.
Okay, so that makes sense. But how would we do it then in the order example here?
Okay, so here we've redesigned our order entity into being an entity snapshot. So if you look closely, you'll see that it pretty much looks like a domain primitive, right?
That's right.
We enforce a bunch of invariants that are domain specific. It's immutable. You can't change this object, right? But the only thing is that we have this order ID, and that's really is the difference. We have this concept of identity. But otherwise, it's very similar to a domain primitive.
So this is pretty neat then. You're saying that by enforcing, invariants or checks when you create this order and make it immutable, we can, I guess, build on the same principles as a domain primitive. And we can share this between threads. We can scale. Oh, wow, so that entity actually became a lot more available.
Yeah.
Okay, that's fantastic. The only problem now, Daniel, is that we need to mutate.
Oh, yeah, that was the whole thing.
That was like the thing we were trying to solve, right? So how do we do it then?
Well, the way we solve it is that we create something different to mutate. In this case, we call it a writable order. Mm-hmm. And the only thing you can do here is mutate the state of a specific order. You can't get the state. Like, there's no get methods, just voids methods.
So this only allows modification.
Exactly.
Wow. So we have separated, I guess, writing from reading. Isn't that quite similar to the CQRS pattern that Greg Young is talking about?
It's extremely similar. It's the same basic concepts. You can also draw parallels to like the single writer principle. You try to separate. And then why this is good is because you're basically using separation of concern and make your code easier to read, less bug.
Right, and I guess if we go back and try to reference this back to the CIA principle now again, we can see that by separating read and write, we sort of enable confidentiality checks, right?
It becomes much easier.
Yes, if you use a microservice architecture, it could be that the writing service is over there, and only certain users have access to that one, and you have the read service over here, and it doesn't matter if you somehow hack the read service, you won't be able to change that data.
So it becomes a lot easier to uphold the confidentiality.
Yeah.
And again, with the separation, it becomes a little bit easier to uphold the availability, because here on the right side, you can really focus on just doing the synchronization and things like that.
So that's pretty neat.
So again, we're solving those CIA issues by primarily focusing on the design again. Mm-hmm. Okay? We don't want you to start thinking about CIA all the time. Focus on the design principles.
Okay, moving on. So now, at this point, we have learned two very important patterns. We know that we can use domain primitives to just, create precise, defined behavior in our building blocks. And we can use entity snapshot to deal with mutatable state and simulate the behavior of a domain primitive.
Okay, so this sounds great, but you know, it's probably great when you're in like a greenfield project, but for us who are in the brownfield world, we have an existing code base, a lot of legacy code. Does this work?
How many of you are doing greenfield? Come on, anyone? Yeah. No. Oh, yeah, I got 2 arms over there. That's good. Okay.
You're in a startup and you're not earning anything.
Yeah.
No, just kidding. But yeah, so, how can we apply this in our everyday life?
So we actually have 3 very good design patterns that you guys can use, I guess, tomorrow, if you like, or today. And the first one is called draw the line. And draw the line is really about starting to identify how bad your data is. Because what we want to do is to create domain primitives, right?
Yes, you start defining and creating your domain primitives, and then you start using it. But like Daniel said, you know, in the real world, data tends to be bad, or maybe you've spent several years of patching bad input and try to do something sensible with it. So if you just put a domain primitive at the entrance of your system, you're just going to break the system. So that doesn't really work.
So to do this now, we can't just add our domain primitives to our code, because what happens if you do that? Well, you break things. Or at least you make it explicit that data is bad. So one way is to add let's say a hidden translation layer just behind your API. And you get your strings, your objects, ints, or whatever you get, and you try to translate them into a domain primitive. And if you're really tough, you can go, I'm just going to reject bad data, but then you get that problem of breaking things. Or you can log it, right?
Exactly. So what you're saying is that you try to create this domain primitive, blows up in your face, and then you log that. So you can start finding the spots where bad data enters, and then you can gradually start to refactor towards either better data or better logic to handle that. And the goal is, of course, that eventually you will be at the point where you can actually enforce the invariants by actually using the domain primitives, not just trying to use them.
So when you end up in a state where you actually say, I'm pretty confident about the data now, we've cleaned it up, it's pretty good, now it's time to actually force your expectations on your consumers, right? So at this point, we should actually start expressing our, how should I say, requirements on our users. So in this case here, we have a generic one. That was the old way of doing it. You pass a string and an int when you bought a book. But the specific now, what you require in your domain is really an ISBN and a quantity. Because an ISBN is really tricky, to be honest. But what happens if you have a lot of consumers? How do you deal with it then? Yeah,
you're probably not going to be able to force the consumers to upgrade to your new Shiny API at once. So, of course, you probably will introduce a new API that does use domain primitives and so on. And you deprecate the old one and you try to gradually move the consumers over to the new API.
Right.
And, of course, under the hood, the consumers that are calling your old API, you can just kind of convert it so the old API actually calls the new logic. And you're gradually starting to use your domain primitives to harden your APIs, your public APIs.
What about, inwards? You're still, messy inwards, right? I mean, inside of your component.
So once you have this good protection of your API, then you have to deal with all the code that you have. So this example is a typical, maybe you have an entity that is a bit messy. You take in a string representation of an ISBN, an int as a quantity, and in this case, we're checking that the ISBN is valid, right? We want to add a book to this order. So we have all these checks. And it turns out that there's a bug here, right? We forgot to check the checksum of the ISBN to see if it's a valid ISBN. So what do we do?
The thing is that I did it over here in this other piece of code.
Yeah, so we solved this by adding a line, making sure the checksum is correct, but we forgot to add it over there at Daniel's place. So you have all these issues. So if we instead start to refactoring and introducing domain primitives, then we get something like this. So you're encapsulating all the invariants into the domain primitives, and then you know that everyone who's using an ISBN can assume that it's valid. Otherwise, it wouldn't exist.
So the neat part here is that because of the definition of a domain primitive, we know that it's true by design. Otherwise, we wouldn't have been able to create it. We would have checked all the checksums, we'd checked that it's only contained digits, whatever it does, right? And the same thing goes with quantity. In our domain, a quantity is defined between 1 and 200, and not like an integer that could be a negative 2 billion and positive 2 billion.
Yeah. So you're gradually making your code more robust, easier to read, and when you reduce bugs, you actually reduce security issues. Because, to be honest, a security bug is no different from any other bug that you spend all your days fixing. There's nothing magical about them. So if you can reduce the amount of bugs, you're actually getting more secure code by default.
Okay, so this is fantastic, but as developers, we're kind of used to working with continuous delivery and our build service, running our test suites. Can't we check security all the time?
Exactly. Just the way we make sure the business feature is working all the time, we should check that our security features works all the time. Mm-hmm. And this can be a pretty broad topic when you get into unit tests, integration tests, system tests, deployment tests, everything. But we're going to talk a little bit about the lowest level, the unit testing part, because it's closest to the code.
Is anyone doing security checks with their unit tests today? Not a single one.
Oh, one there.
Yes, you're our friend. Okay.
Okay, so maybe you are, but you're not conscious about it.
Yes.
So what's the very basic type of testing you do when you're writing code? Why is this important?
To explain this in a good way, this is actually a real-world example, but we can't really, how should I say, reveal where it was.
To protect the innocence, we've altered the story. It could be a hospital, it could be something else.
Could be something else. But the case was this, that doctors and nurses, they were all using a very advanced medical system, and they were communicating, about sensitive patient data.
Medical journals, medication and everything like that.
In this system. And
so I guess it's very important for that system to make sure that the data doesn't end up somewhere it shouldn't end up.
Exactly, and the underlying mechanism in this system turned out to be email-based.
Okay.
That's how they commuted.
A bit odd, but yeah, maybe it makes sense.
Okay.
It's a standard way to pass information.
Of course, then we need to be sure that, if you pass a message to someone, we need to make sure that since it's email, we only accept hospital.com, right?
Okay.
Otherwise, we could get, you could leak out data to a third party, and that's kind of bad.
Yeah, you don't want to send the medical journals to Gmail or something.
Right.
Now, I know how an easy fix for that. The only thing you have to do is make sure you configure your email servers not to send emails to something else than hospital.com. And since I'm a security-minded person, I would probably firewalls and stuff like that to protect no outbound SMTP traffic. Problem solved.
Okay, Daniel, to be honest, that's exactly what they did. Okay, they created this perimeter-based security around their system.
So what was the problem?
The problem was that they upgraded the firewalls or the email servers, and those settings, either they got overridden or somehow lost in that upgrade. And sensitive data actually leaked out without anyone noticing.
Okay.
So in order to address this, we're going to show you now how we can use, testing and actually create or derive a domain primitive called email address in order to create security in depth. And security in depth is actually that if you break one layer of security, you just hit the next one and the next one and the next one. So it actually becomes secure throughout. And we're going to do this without actively thinking about security.
Okay, so we're still keeping the the configuration of the email servers, but we're also making it hard to do the wrong things in the code.
Yes.
So let's go back to, when we talked about domain primitive, we said that it was important to define it in the current context, right?
Mm-hmm.
So in this case, our context would be, a valid email would be something with hospital.com domain, right?
Yes. If you look on the left there, you would see, you know, every possible email, like it could be something for Gmail or some other address that you have. But on the right there, we have a context where only addresses in the hospital.com domain are valid. Everything else is considered invalid.
And then maybe you have more rules like certain lengths and you know,
yeah,
a lot of domain-specific rules.
Exactly. So as developers, what we tend to do is that when we write our tests, we start by what I would call normal testing. That would be, you know, testing john.doe or jane.doe at hospital.com. Does it work? So it's like vanilla testing, right? It obviously should work for this kind of input. And when you're done and satisfied with that, you will go for boundary testing, right?
Yeah. Which is, I guess, you're testing the normal, and then you're just testing data that is just outside of the valid boundary, and then right inside.
So that could be like saying jane.doe at hospital.pl. Sort of, I've just changed one a little bit, and it's just right outside, or it could be a little bit too long address or too short if that's a requirement, and so on, right?
Yeah, that's the typical approach that most of us do when we write tests. So we did that, and when we start applying that, we get an email address, an implementation of the email address that looks like this. This is the version 1. So this is the version that, you know, with the current testing fulfills all the domain rules.
Right, and since everybody is a regular expressions specialist in this room, we won't actually dig into that regex, but I guess the essence of it is that we're checking for, it has certain length requirements, it contains only a certain type of characters, and it should be, you know, ending with hospital.com. So at this point, a lot of us just stop. This is where we say we're satisfied, the email address is good.
It's a fairly good domain primitive, but I think we can do better than this.
Yes.
So what if we start adding more tests?
So one of them.
What if we do invalid input testing? What's that?
Yeah, the invalid input test is actually something that's broader than, you know, boundary tests. We're going to test with data that's further out, so to say.
Okay, so if I'm understanding you correctly, we're testing things that are obviously invalid.
Yes.
It's not even supposed to be valid. This, compared to the boundary testing, like,
yes,
this is very much invalid.
But it could also be like saying, I mean, we could use addresses that look pretty legit, but they are invalid in our domain.
Okay.
Okay, so let's see. We're going to look at this piece of code here. This is JUnit 5, so don't get too intimidated about it. Basically what it is that we have a stream of input, and then we map that to a dynamic test, and we execute.
But the interesting part is the data itself, right?
Yes.
You're testing null, and you have some tab signs and really weird data. It's invalid data.
So the key here is that this is really your imagination along with the domain experts in trying to identify what kind of data is invalid in our domain. And obviously, we should reject it, right? So when we do that, and when we ran this particular test, it turned out that we had forgotten an explicit null check.
Okay, but you know, I get that, but wouldn't we still get a null pointer in the old version?
Yes.
So what's the difference of adding an explicit invariant for it?
Oh, okay, good question. The thing is that when you get a null pointer exception just by accident, that's really not part of your contract for your code. If a consumer could check what kind of preconditions do I need to satisfy in order to, you know, use your API, this thing would actually be part of it. We would say, you know, we're not going to accept null values, and we require the address to be of a certain length, certain characters, and so on.
And I guess it's also helpful when you're investigating that stack trace production that you'll see, okay, this is not an accident, it's actually by design, so to speak, that we're not allowing null values.
But the fact, Daniel, we don't stop here. We need to move even further, right? Because all of us now, we know that availability is something we need to consider as well, right? So for that case, we need to actually add what we would call extreme input testing. And what's that?
Well, that's when we're starting to put in data that is ridiculous, I guess, like a gazillion characters is not a valid email address, but we know it will fail, but how does the system as a whole behave? How does your code behave?
So in this case here, we have, in the bottom there, we have a string of 40 million characters, and the question is the design going to handle that well? Is it going to choke, or is it going to just simply reject it like that?
Okay, so what happened with our code? Well, our code passed that test, right?
It did.
But it was by lucky shot or by, good design, we don't know. But the thing is, if we have written our regular expression just a little bit different,
right,
and if we had excluded the explicit length check that we had,
then we would actually have ended up in inefficient backtracking in the regular expression engine.
And what does that mean in practice? What would happen if we pass in a huge amount of data?
Well, we would halt, more or less. I mean, we would consume all the CPU, I guess.
Yeah. The mechanism trying to resolve the regular expression would just go on for a very long time, maybe forever.
So we would have affected availability. Also, an important note here is that when you add that test, everything works fine, but someone might look at that regular expression and go like, you know what, I know a better way to design it, and we all know that regex are really difficult to deal with. So if you do it a little, less efficient, it's going to blow up. Yeah. And that's pretty neat to catch.
And we're touching on a subject that is really interesting, that is how you should actually enforce your invariants. How should you validate the input data? And one of the aspects there is that one of the first things you should do is to check the length or the size of the data, which is the key important part here.
Yeah, it's exactly a topic of its own. Yeah. It's pretty big. So just keep that in mind. Okay, so we have covered, the design patterns, and now we also know how to apply security in our, unit tests, and we can somehow derive secure software without really thinking about security, only design.
Yeah. Okay, so all these patterns are protecting us from things that happen because of someone doing something malicious, sending corrupt data, trying to do an operation they're not allowed to do. But what about security issues that arises because you're doing something valid?
Right.
You're doing things you're supposed to do, but it turns out to be malicious.
And that really brings us into that, that threat that we were talking about. Yeah. And in order to understand that, we need to understand what a denial of service attack is. And probably a lot of you know what it is, but just to bring everybody up to the same level, we would say that if we somehow interact with our system in a way that would make it totally unavailable, we have succeeded. And one way, of course, is to use a lot of servers or making a lot of requests. And then we can't serve everyone, and therefore we can't use that system.
Yeah, but from an attacker's point of view, a good attack would be something that is asymmetrical. So it's a little, if I'm the attacker, I want to have a small effort result in a big effort on the receiving side.
Right. So the cost for doing an attack should be cheap for the attacker and expensive for the ones that get attacked.
Okay. So what if we move into the term domain DOS? Well, you're doing something that is, you're just using the valid domain rules, but you're using it in a way that is malicious. That's what a domain DOS is.
Wait a minute. Are you saying that by simply using the system as it is intended, I'm able to somehow make it unavailable?
Unavailable, or causing financial harm, or whatever you're trying to do. So
Wow.
let's look at a real-world example.
Okay.
Let's say I'm operating a hotel. If my clicker works. Yeah. So I'm running a hotel, and I'm a business developer at the hotel. So I'm thinking, we should maximize the customer service. How can we make our customers more happy?
Okay, I guess we could say that, you can cancel your bookings free of charge before 4 p.m. at the same day of your stay.
That's a pretty good offer, right?
Yeah, flexibility.
You check in at 12, but if you don't show up, you just call and say, yeah, I want to cancel my booking, and you get a full refund. That's great. Customers are happy, but what if someone else, maybe a competitor, books all the rooms on your hotel and then cancel it on the day where you're supposed to arrive? Your real customers are not going to be able to book in rooms, and everything gets canceled, so you're ending up with an empty hotel not making any money. That's kind of an attack, right? But you're just using the rules.
Sure. But I mean, in the real world, who does that? I mean, that won't be a problem.
It turns out, it actually happens more than we think. In India, everybody knows about Uber, right?
Yeah.
It's like this internet-based taxi sharing thing, really popular. In India, there's a company called Ola, which is basically like the Indian version of Uber.
And it turned out that Ola, or actually this is what Uber claims Ola has done. There's still a lawsuit going on. I guess they registered, I think it was 90,000 fake accounts.
Yeah, and then they registered like 400,000 or 500,000 rides.
Right.
Like a ridiculous amount. And then they canceled the rides after a little while. So all the drivers were, I got a ride. They're going to pick up the customer, and then you cancel it. Oh, nothing. So the Uber cars just driving around without customers. And of course, customers trying to get a ride at Uber had to call Ola instead, because you can never get a car from Uber.
And the funny thing here is that this is according to the domain rules. And of course, Uber, they're going to have a hard time creating business. And they're the innocent ones here, right?
Yeah.
Or
the irony is that about 2 years earlier, Lyft accused Uber to do the exact same thing, right? So we're not judging anyone, but it happens, and we're just using the system as you're supposed to. You are allowed to book a ride, and you are allowed to cancel the ride. You can cause some pretty good harm by doing that.
So one thing you guys need to think about when you go back to your own projects, your own systems, is it possible to use your domain rules, your business rules, in a way that potentially blocks out the usage or, impairs availability?
Yeah, and the important question is, of course, how can we protect ourselves against this? Well, in some businesses, they're actually pretty used to this type of behavior. And one thing you can do is try to monitor the standard behavior and then see if you see anomalies. You can detect those. Let's say in trading, you're allowed to buy and sell stocks, but then you can buy and sell stocks in a way that is illegal. Then you have some kind of fraud detection, right? And they monitor all the trades on the stock markets, and they can see various behaviors. That's one way to detect, maybe not prevent something from happening, but you can detect it afterwards, and you can find out who did it and possibly prosecute them. So that's a business that's very used to this, but I think more and more industries is going to have to start thinking about how to protect it against these types of attacks.
Okay, so in case you fell asleep and now you wake up, you'll find out that the key takeaway here is that by focusing on good design principles, we're able to create secure software without actively thinking about security. And it's pretty neat. We used our domain primitives to enforce certain rules, and we can use entity snapshots to get our availability going. And then we can start using good testing in order to flush out security problems in our daily code.
Yeah. And again, we're not saying that this is not replacing specific security tests, penetration testing and so on, but it's a complement, and it's a lot easier to attain, in our experience, for the everyday developer that might not be that interested in security or might have a deadline to meet and so on. So it complements all the other stuff that you do to ensure your software is secure.
Right. And now it's time for our shameless plug, of course. In case you were really interested in this and thought this was kind of cool, Daniel and I, together with a colleague, we're actually writing a book about this called Secure by Design. And there's a discount code that allows you to get 40% discount. You can join the early access program, so you can read chapter by chapter. And you can give us feedback on that and say, hey, I did not understand that, or maybe we should do it this way or that way, and we can, create an awesome book about this.
Yeah, and in a way to say thank you for Devox, we're giving away a couple of free ebooks, so if you're interested, you can catch us. We'll hang out outside in the break. You just come up to us and talk to us. And I think we have time for a few questions, if anyone is wondering something. It's a microphone down there, too.
Can you hold your hand up?
Here we go. There's a question over there. Yes.
I have a question regarding primitives, these data types. Does it mean that you should wrap all the primitives, like all the strings, in your domain objects?
Okay, so the question, yeah, pretty much. So the question, if I understood you correctly, is should we drop all the standard language primitives in your domain code? And I would say the answer is yes. The smallest building block tends to always be the domain primitive. Because once you start to think about how do we really represent our domain, very rarely think just an integer. It always has some meaning, and the way you want to represent that meaning is by creating a domain primitive.
I think there might be time for one more question. Well, if there are no questions, thank you very much.
Thank you for having us.